Hey, algebra students, welcome to today's lesson on the introduction to two variable inequalities. So let's start with just a little warm up to see if you guys remember how to plot points. Go ahead and pause the video right now, and I want you to graph and label the following ordered pairs. Make sure when it says graph and label that after you plot the point, you also put the letter next to the point so that we know which one is which, okay? So please plot points A through F, pause the video, and push play when you're ready to check your work. Okay, so remember that ordered pairs are written in alphabetical order, x comma y. The x-axis is the horizontal axis and the y-axis is the vertical axis. So you always start from the origin, which is at 0, 0 in the middle. So for point A on the x-axis, I'm not going to go anywhere since the x value is 0. But then on the y-axis, I'm going to go down 1 because it's negative. So that's point A. For point B, I'm going to go 3 on the to the left on the x-axis, and since y is 0, I'm going to stay put. That's B. C is 4 to the right and down 2, since the 4 is positive for the x and the y is negative. And then I'm going to continue and plot the rest. How did you do? Okay, so if you struggled with this or you forgot about it, remember you can always come in for help with a teacher and practice some more. Okay, so again, don't forget ordered pairs are written in alphabetical order, x comma y. Think of the alphabet, right? W, X, Y, and Z, X before Y. Okay, so let's take a minute to read this situation about Marco. Marco is making bracelets. He's using planet beads and oval beads. Planet beads cost $1 and oval beads cost 2. So we're talking about two types of beads. Planet beads, which have a different price than oval beads. Okay, and you can see in the picture the oval beads versus the planet beads. When I was younger, one of my most favorite hobbies was making jewelry. Okay, it also mentions that he wants to make at most $10 on beads. So think about it. What does at most mean? Does that mean he wants to make more than $10? Does that mean he wants to make less than $10? Or spend more than $10 or spend less than $10? Can he spend exactly $10? So you should already start thinking what inequality, right, applies. So they kind of already told us, right, in case you haven't noticed, which inequality we're going to use. They want to use less than or equal to 10. Because he can spend less than 10, he can spend up to 10, but he does not want to spend more than 10. So it has to stay, that quantity has to stay lower than or equal to 10. All right, 2.1. What does each part of the inequality below represent in Marco's situation? Well, let's take one at a time. The 2 is the price of what? It's the $2 price of the oval beads. So that means that the x represents the number of oval beads that he can buy. Now there's a hidden 1 in front of the y. That 1 represents the $1 price of the planet beads. That means that the y value represents the number of planet beads he can buy. And last but not least, we have the less than or equal to 10, which is that he can spend $10 or less. You can also just say at most $10 if you'd like. Okay, so make sure that you have all those parts labeled and that they make sense. So the difference between this lesson and the ones we've done before is now we're looking at two variable inequalities. So notice that this, right, this problem was talking about an X, the oval beads and the planet beads. So there's two variables. Every inequality we've looked at so far only had either all one variable, right, all X's or all Y's or all M's. They all had one variable. Now we're going to start looking at two variables. And whenever you start mentioning two variables, X and Y, you should be thinking of the coordinate plane and ordered pairs that come in X comma Y, ordered pairs. So they made a sketch for us of the graph. Notice that the dollar beads, which beads cost $1? Do you remember? So the ones that cost $1 were the planet beads. So this one is talking about the planet beads. So the y-axis represents the planet beads, and then the $2 beads are the oval beads. And that's going to be represented on the x-axis. Notice that there's a lot of ordered pairs that represent the situation, and there's actually more answers than what is just shown on the graph. So these are the different combinations of planet beads and oval beads that Marco can purchase that will cost less than or equal to $10. Okay, you are now going to choose a point shown on the graph, and prove that this point is a solution. So think back to how we've used substitution to prove that something is a solution to an inequality. Now remember, there's lots of options here, right? Of ordered pairs you can pick. You just need to pick one. Once you pick your point, so let's say I know which point I'm going to pick, one of the ones that's been given, right? You're going to pick it. You're going to substitute it into your inequality, and you want to prove that it is a solution. So in order to prove that it is a solution, you need to be left with a true statement. Okay, go ahead and pause the video. Pick a point that would work when you substitute it. Now there's lots of different possibilities you could have picked. So I'm just going to show you the one that I chose. So I chose the ordered pair 2, comma 3. So 2 on the x-axis, 3, that's this guy right here, 2, 3. So 2 for the x and 3 for the y. And if it truly is a solution, when I simplify this, 2 times 2 is 4, 4 plus 3 is 7. This is a true statement. 7 is less than or equal to 10. Okay, so now this next section says choose a point that is not shown on the graph and prove that this is a solution. So I want you to give me an ordered pair, a point that is a solution but is not visible on the graph, and you're going to prove that it's an answer. In order to do that, you have to try to kind of find a pattern here, okay? Notice that all these points are kind of in this little area here, right? So try to pick an ordered pair that is not already plotted, but it would be in that general yellow area that I highlighted. Once you pick your point, you're going to substitute it. And again, don't pick a point that's already visible. Pick one that's not. You're going to substitute it into your inequality. to prove that you get a true statement, right? Because we want to prove that it is a solution. And you got to pick one that's not shown on the graph. Okay, go ahead and pause the video now. Make sure that you show your work. Ask a teacher if you're not sure. Okay, so for this one, I could have picked a point like 0, 3. Okay, here's 0, 3. If I substitute it in, 2 times 0 is 0, plus 3 is 3. 3 is less than or equal to 10. That's true. Yay! Now, if you had picked a point that doesn't work, you just try again. Okay? So let's say you would have picked 5, 3, right? Let's see, does 5, 3 work? 5, 3. Doesn't look like it's in the shaded area, right? But we could say, hey, I don't know, maybe it'll work. So if I substitute 5, 3, 5, 3, 2 times 5, so this one would not be a solution. You'll see. 2 times 5 is 10, plus 3 is 13. 13 is definitely not less than or equal to 10. That's false, right? So if you picked a point and you substituted it, but it didn't give you a true statement, then you just pick another one. But in general, you had to pick one that kind of followed the area, right? The pattern that was visible where all the other points were. Okay, go ahead and flip to the next page and read this story. Make sure that you circle or underline anything that you think is important. Okay, so I noticed that they want me to say or to pay attention that student tickets are the X and they cost $5, right? So all these things are related. Then we're also talking about adult tickets and they want us to use Y to represent the adult tickets. So the theater club wants to buy costumes for a show. So they want to make at least $180. Question 3.1 says, explain how you know this situation is an example of a constraint. So constraints, if you think back to a couple lessons ago, constraints are a limitation on a specific quantity. So they definitely want to make at least $180. So it's like a restriction. They don't want to go lower than 180 because then they might not be able to afford their costumes. So how do we know the situation is an example of a constraint? Since they used the word at least, so since they want to make at least 180, that shows a restriction or a limitation, okay? Meaning that they have goals, right? They have a goal they want to meet. They want to make at least 180. So words such as at least, at most, does not exceed, no more than, no less than. Those are from, I believe, a couple lessons ago, maybe lesson 10. So take a look at your vocab if you forgot some of that stuff, but you need to know that constraint is talking about an inequality, okay? All right, so again, a constraint is an inequality. So with inequalities, there's a couple options, right? You can have a less than or equal to, greater than or equal to. And we needed to represent the situation. All right, well, let's start with what they're selling first. They're selling student tickets for $5. The student tickets are, we're going to represent them with the letter X. Now you can put the $5 sign if you want, or the dollar sign, or you don't have to. And they're going to take that money plus the money that they make from selling adult tickets, which is $7. An adult ticket per ticket, the tickets are Y. And they want to make at least $180. So think to your choices right here. If they want to make at least $180, we're going to have to choose between this one and this one, because for them their goal is at least 180. So if they make it at least to 180, that would be good enough. But they want to make at least 180, meaning 180 or 181, 182. So 180 or more. Okay, so at least means that they want to get to that dollar amount or more. So then out of those two choices that I highlighted in pink, we want to make more or exactly 180. Okay, go ahead and read this next problem. Think about if you know what it is asking. All right, so we're dealing with this inequality. X plus 1 is greater than y. And they want us to write three coordinate pairs. So remember, coordinate pairs are ordered pairs, x comma y, that are solutions to this inequality, meaning if I substitute them back into the inequality, it should give me a true statement. Use the graph if it helps with your thinking. Okay, well, in these situations, I think it's easier to start by picking a couple of x values. So let's say I pick something easy like 0, 1, and 2. Okay. If I substitute 0 into my inequality, remember your inequality is x plus 1, so x plus 1 is greater than y. So if I substitute 0, I get 1. So that means I need to pick a number where 1 is bigger than that y value, okay? So this is saying 1 is bigger than the y value. So here are my y values, y-axis, right? Here, these are the y values. So I want to pick a y value that is smaller than 1. So here's 1. I need to pick a y value smaller than that. So I could pick 0, I can pick -1. Anything lower than 1 would count, okay? Because again, this part is saying that 1 is bigger than my y value. Okay, so pick any y value smaller than 1. I'm going to go ahead and pick -3, okay? But again, you just had to pick a number smaller than 1. Let's practice another one. So I picked an x value of 1. So if I substitute it into here, that gives me 1 plus, oopsies, I don't know why I put 2. Sorry, kids. Okay, so 1 plus 1 is 2. So now I want 2 to be bigger than my y value. So I can pick any y value that is smaller than 2, right? Because 2 has to be bigger than my y value. So I could pick any point, any y value that is lower than 2. Go ahead and pick any number that is lower than 2. I'm going to pick 1. Remember, there's more than one answer. You could have picked -4. You could have picked -20, right? Isn't -20 smaller than 2? Okay, last but not least, I'm going to substitute an x value of 2. 2 plus 1 is 3. So I want a y value to be smaller than 3, right? Because this is saying 3 is greater than the y value. So as you choose your y value, you got to make sure that 3 is bigger. So now we're looking from 3 and lower. So you could pick 2, 2.5, 1.8, negative 4.7. You can pick decimals, fractions. You could get creative with it. I'm going to go ahead and pick another negative number. So I'm going to pick negative 10. Negative 10 is definitely lower than 3 or smaller than 3. All right, guys, as always, if you need extra help, don't forget to reach out. And I hope you guys have a good day. I'll see you soon. Bye.